Before we start our next chapter, we're going to review simplifying radicals. So remember, a square root symbol means I need two of the same number that multiply to be the number underneath the radical. And we're trying to pull out all the perfect squares. So the square root of 49 is 7. Square root of 48. You have to break 48 down into at least one perfect square. So 48, the largest perfect square that goes into 48 is 16 times 3. 16 times 3 is 48. Then I can simplify and break that radical down into two separate radicals. Square root of 16 is 4 times root 3. So the answer of this one would be 4 root 3. We can't have any radicals in the bottom. So part C. First you want to do kind of the reverse of what we did in B. With a fraction, if you have a radical sign on the top and the bottom, I can write that under one radical. First, try and simplify that fraction. Well, 3 goes into both of those, so that's going to simplify to 2 over 5. Now break that radical down into root 2 over root 5. Now again, we can't have any radicals in the bottom, so we have to rationalize the denominator. How we rationalize the denominator is you take and you multiply by what's ever in the denominator on the top and bottom. So the bottom, root 5 times root 5 is just 5. Now you can multiply the 2 times the 5 under one radical to get root 10. So your answer here is root 10 over 5. You cannot cancel the 10 and the 5 because the 10 is locked underneath a radical. Now D, if you have variables and numbers, break the number down. So 75 is 25 times 3. X cubed. Well, x squared is a perfect square times x. Y to the 6th is y squared times y squared times y squared. Because remember, when you have the same base, you add the exponents. So here this is going to simplify. The 25 simplifies to a 5. 3 can't be simplified anymore. X squared is just x. Y squared, y squared, y squared. That's y to the 3rd. So I've taken care of the 25. I pulled that out in front. I've taken care of the x squared. Taking care of those. So we're just left with a 3x inside. So I have a 5x y cubed. Inside our radical, we have a 3x. Now some higher powers. What this number up here means is I need 3 of the same thing, or a number to the 3rd power, or a perfect cube, to be able to break that number out from underneath the radical. So break 27 down. 27 is 9 times 3. Well, 9 is 3 times 3. So the prime factorization of 27 is the cube root of 3 cubed. The cube root and the cubed essentially cancel, so we get 3 there. Here, I need 4 of the same thing. I need something to the 4th power that's going to multiply to be 32. Well, let's break 32 down. 32, 8 times 4. 2 times 2. 8 is 4 times 2. 4 is 2 times 2. So 32 is 2 to the 1, 2, 3, 4, 5th power. But I needed 4 of the same thing, so let's look at that a different way. That's like saying 2 to the 4th times 2 to the 1st, because with the same base, I add the exponents to get 5. Well, 2, the cubed root, or the 4th root, I apologize, 4th root of 2 to the 4th times the fourth root of 2 to the first. The fourth root of 2 to the fourth is just 2. Fourth root of 2. I put that the root kind of inside the radical sign because so that it doesn't get confused with that too. So that would be our answer there. Now some math involving radicals. So let's simplify each one of those radicals. So first let's pull out any perfect squares. 48 can be written as 16 times 3. There are no perfect squares that multiply into 3. So I have 5 times 4 times root 3 minus 12 root 3. That's going to be 20 root 3 minus 12 root 3. The only way you can combine these is if what's underneath the radical is exactly the same. They are, so 20 minus 12, that's going to be 8 root 3. Here we're multiplying two binomials together. What are we doing? We're just doing FOIL. First terms together. So I have multiply the numbers outside together. So I have 8. Multiply the radicals together. Root 3 times root 3 just multiplies to be 3. The outer terms together. Multiply the numbers together. So I have 4 times 3, that's 12 root 3. Inner terms together. 10 root 3. And then our last terms together, minus 15. Now simplify even more. 8 times 3 is 24. Minus 15, because I can move different terms around. And then I have plus a 12 root 3 minus a 10 root 3. 24 minus 15 is 9. And then a 12 root 3 minus a 10 root 3 is a positive 2 root 3. 2 root 3. Now when you're squaring, there's two ways you can remember this. What you can do is you can just do FOIL if you want. Remember, squaring, you're multiplying the same thing twice. So multiplying the first terms together. 2 times 2, that's 4. Root 2 times root 2 is 2. So that's the first terms. The outer terms is minus 3 times 2 is 6 root 2. The inner terms, minus 6 root 2. The last terms, plus 9. So I had 8 minus 12 root 2 plus 9. 8 and 9 is 17 minus 12 root 2. Now there's a shorter way to do this. If you remember multiplying out a perfect square, a plus b squared, first term squared, minus, I had two middle terms, plus 2ab plus b squared. So if you think of that as a, you think that as b, let's see what happens there. Well, I have a minus, so actually here, in the middle here, that's going to be a minus sign, and this is going to be a minus sign there. So a squared, a, we said was 2 root 2. 2a times b. So I'm going to write out 2 times root 2 times b plus b squared plus 9. Well, 2 root 2 squared, that's 2 times 2, so that's 4, times root 2 squared. Root 2 squared is 2. 2 times 2 times 3. 2 times 2 is 4, times 3 is a 12 root 2, plus a 9. 4 times 2 is 8, plus 9 minus 12 root 2, 17 minus 12 root 2. And that's the same thing that we got above. It's just a shorter way to do it. You might want to remember this because it's going to make your life easier later on when we get to some different solving equations. Okay, D. These two radicals are what we call conjugates. They have the same first number, same radical, just the sign in the middle. One's plus, one minus. Something really interesting is going to happen when I FOIL these out. So let's do first terms together. Outer terms together. Inner terms together. Last terms together. Look, the middle terms go away. So I'm left with 4 minus 3, which is 1. So when I multiply a radical by its conjugate, the radical goes away. That's going to help us on our next problem. Our last example. We need to simplify the following. Like I said before, you can't have any radicals in the bottom. So to get rid of this root 5 in the bottom, we need to multiply by, again, the conjugate. So if I multiply by 1 plus root 5 over 1 plus root 5, the conjugate of the bottom, same first term, same second term, just a plus sign in the middle, the opposite sign that I see there. Let's see what happens. Okay, so let's work with our bottom. First terms together, 1. Outer terms together, root 5. Inner terms together, negative root 5. Last terms together is 5. So just working with the bottom for now, those middle terms cancel. I have 1 minus 5, that's a negative 4. Now let's work with the top. First terms together, that's 2. Outer, 2 root 5. Inner, root 5. Last terms, root 5 times root 5 is 5. So I have a 2 plus a 5, well that's a 7. I can combine the radicals because they're the same radical, plus 3 root 5. If I multiply the top and bottom by negative 1, that just might make it look a little nicer, but either one of these answers would be correct. So when you have 2 terms on the bottom and you're trying to simplify the radical, you need to multiply by the conjugate. If I just had 1 term on the bottom, like say for example I had root 5 over root 3, you just multiply by exactly what that radical is to get the radical out of the bottom. So you get root 15 over 3. Again, the 3 and the 15 cannot cancel. The 15 is locked underneath the radical. If you have a number, looking at this number, if the bottom number, if there's a number that's in the bottom that goes into both the 7 and the 3, then you can cancel. But you can't cancel with just one. There are your lesson questions for the day.